This is my latest, greatest, and final attempt at making the ultimate 3D printed RC car. And honestly, I think I've actually pulled it off. So buckle up because this is the story of how I built the best 3D printed RC car in the world. Before we get into the video, if you're looking for a full build tutorial or a complete and in-detail breakdown of the CAD and designing process, I'm going to be making separate videos for those. If you quickly want a build manual, you can check out the link on my Makerworld. It has all the information on how to make the car. Also, if you want to be updated on my latest and previous projects, you can check out my new website, hydrancerobotics.com. If you want to build this car but don't have a 3D printer, you can buy a starter kit. Or you can buy the entire car. And feel free to contact me if you have any questions. Now, let's get into the video. If you've been following my channel, you know that this isn't my first rodeo with 3D printed RC cars. I started with a pretty basic 30 km/h rear wheel drive model. Then I doubled down and built a much tougher 60 km/h full 4-wheel drive version. But I kept seeing these YouTube videos of people pushing their RC cars past 100 km/h, absolutely bashing them and going totally wild. So I knew I could not stop here. I needed to upgrade my design once and for all, and so I did. My newest 3D printed RC car hits 100 km/h. Features a full metal drivetrain built to take a beating, and is easily my most rugged design yet. To ensure this car can handle the extreme stresses of hitting 100 km/h, I had to completely redesign everything from scratch. That came with a few critical design decisions along the way. First up, the steering assembly got a massive strength upgrade. Instead of relying on two tiny M3 screws as posts, I switched to a beefy 12mm post riding on 12x20x6 bearings to carry the load. The steering arms are now 3 times larger and nearly double the thickness of the previous version. The entire system is also balanced with a dual-sided support structure to completely eliminate high-speed wobble. This makes the steering system extremely robust. And it really proved itself in this crash. None of the steering components broke at all. The frame was the next major overhaul. It's now longer, wider, and twice as thick to handle the extra forces and accommodate a massive quadruple-sized battery, along with a powerful 120 amp AC. I also shifted to a modular design this time around. Now everything is a separate, easily replaceable part. Then there are the suspension arms. These are much larger, longer, and feature complex geometry to balance out the intense loads acting on them. For the motor, I designed a proper mount this time. No ugly screws ruining the paint finish. Instead, it bolts directly into the motor's factory mounting holes. Finally, there was a material choice. So after doing some research, I decided to try a new filament, 72D TPU. It retains the incredible impact resistance of softer TPU, but when printed correctly, it's almost as stiff as PETG. It's made printing really strong parts for this RC car much simpler. Whether you're building a custom drone, upgrading your keyboard, or engineering a mechanical device, getting your hardware made should be the easy part. That's where PCBWay comes in. They are your one-stop shop for high-quality prototyping. They offer rapid, reliable PCB prototyping, full component assembly, and advanced 3D printing. Click the link in the description for a discount on your first order. Now back to the video. I also tried to simply solder some LEDs onto the battery charging leads just so that I could get some decent headlights, and it worked for a while, but after a few bumps and crashes, they just stopped working, so I'm gonna have to look into something more robust if I really want to make a good headlight. Once I got everything printed and built, off to the parking lot I was to start testing it. In this short clip, I wasn't looking where I was going during a high-speed test, and I crashed straight into a curb. I was probably going like 50 kilometers per hour. The entire chassis was cracked, I nearly lost my camera, and most of the other frame-related components were broken. Only took me like an hour to fix. After fixing it, I took it out to a gravel parking lot to try some drifting. I nearly crashed into my dad.
Oh my god.
This thing grips like crazy. It drifts with no effort. I also took it to a bike park to try and get some jumps in, but it's really hard to see which direction the car is going when you can't really see it on the bumps. This dog really wanted my RC car. In this situation, I steered too sharply, which caused the entire car to flip. This has happened a lot of times. I then took it out for some high-speed tests, but it was so windy that it was just really hard to control. And that led to this. And this is why you should get high-quality metal parts. These cheap Chinese ones break really quickly. The whole wheel connector just snapped off. Here's some pretty cool night clips in the rain. And that's pretty much it for this video. You can get all the print files for free on my Makerworld and Github, links in the description. If you like my work and want to support my future projects, subscribe to stay tuned. Thanks for watching.